A Valentine's Day surprise. West Texas rattles with a 5.0 earthquake. On February 14, 2025, a 5.0 magnitude earthquake shook West Texas. It occurred at 11:23 p.m. The epicenter was located 33 miles northwest of Toyah, Texas. This area is near the border of Culberson and Reeves counties. The quake's epicenter was situated in a sparsely populated area. This region of West Texas is known as the Permian Basin, a hub for oil and gas production. While the earthquake's magnitude was significant, initial reports indicated no major damage or injuries. However, the event served as a stark reminder of the increasing seismic activity in the region. This has been linked to oil and gas production activities, particularly hydraulic fracturing or fracking. The event prompted questions about the effectiveness of current regulations and the need for continued research into induced seismicity. Feeling the tremors, impact and aftershocks in West Texas, the 5.0 magnitude earthquake was felt by residents across a wide area of West Texas and beyond. People as far west as El Paso, Texas and parts of eastern New Mexico reported feeling the tremors. The shaking intensity varied depending on proximity to the epicenter. Near the epicenter, the shaking was described as light to moderate. In more distant areas, it was generally felt as a gentle swaying or rolling motion. Despite the widespread tremors, there were no reports of major damage or injuries. Some residents reported minor cracks in walls or ceilings, others experienced objects falling from shelves. Following the main earthquake, 3 smaller aftershocks were recorded. Aftershocks are common as the Earth's crust adjusts to the displacement caused by the main shock. The aftershocks ranged in magnitude from 2.5 to 3.0. While these were significantly weaker than the main earthquake, they were still strong enough to be felt by some residents in the area. The event underscored the importance of preparedness and mitigation efforts. A history of quakes, seismic activity in the Lone Star State. The February 14, 2025 earthquake was a notable event in Texas's seismic history. While not generally considered earthquake-prone, Texas has experienced a significant increase in seismic activity in recent decades. This increase has been particularly pronounced in the Permian Basin region, coinciding with the boom in oil and gas production. Historically, Texas has recorded relatively few earthquakes. The state's geological records indicate that strong earthquakes are infrequent. However, the recent surge in seismic activity has raised concerns among scientists, policymakers, and the public. The 5.0 magnitude earthquake is just one of several significant events that have shaken the state in recent years. In the 6 months preceding this event, Texas experienced 2 5.1 magnitude earthquakes. Understanding the causes of this increased activity is crucial for developing effective mitigation strategies and ensuring the safety of residents and infrastructure. Fracking and fault lines, unraveling the link to earthquakes. Scientists have been studying the link between oil and gas production activities, particularly hydraulic fracturing or fracking, and the increase in seismic activity in Texas and other parts of the United States. Fracking involves injecting high-pressure fluids into underground rock formations to extract oil and natural gas. While this technology has revolutionized energy production, it has also raised concerns about its potential to trigger earthquakes. The process of fracking itself can cause small earthquakes, known as micro-earthquakes. These are usually too small to be felt at the surface. However, the real concern lies in the disposal of wastewater generated during fracking operations. This wastewater, often containing chemicals and brine, is typically injected into deep underground wells. These wells can sometimes intersect with existing fault lines, altering the stress state within the rock formations. The link between wastewater disposal and induced seismicity is supported by numerous scientific studies. Section 5. Wastewater disposal. A deeper dive into induced seismicity. The disposal of wastewater from oil and gas production, particularly fracking, has emerged as a primary concern in the context of induced seismicity. As the volume of wastewater generated from these operations continues to increase, so too does the potential for triggering earthquakes. Understanding the mechanisms by which wastewater disposal can induce earthquakes is crucial for developing effective mitigation strategies. When large volumes of wastewater are injected into deep underground wells, it increases the pore pressure within the rock formations. This increase in pore pressure can effectively push apart the rocks, reducing the frictional forces that prevent them from slipping along fault lines. Moreover, the chemical composition of wastewater can also play a role in induced seismicity. Wastewater from oil and gas production often contains dissolved minerals and chemicals. These can interact with the rock formations surrounding the injection well, altering their mechanical properties. Injecting wastewater into deep wells that intersect with basement rock has been linked to an increased likelihood of triggering earthquakes. Basement rock is often more brittle and prone to fracturing than the overlying sedimentary layers. Understanding the science behind this phenomenon is essential for developing effective regulations and mitigation strategies to minimize the risks associated with human-induced earthquakes. Section 6, the Railroad Commission of Texas, regulating the oil and gas industry. The Railroad Commission of Texas, or RRC, plays a crucial role in regulating the oil and gas industry in the state, including the permitting and monitoring of wastewater disposal wells. With the increasing concern over induced seismicity, the RRC has faced growing pressure to implement measures to mitigate the risks associated with wastewater injection. The RRC has taken steps to address the issue of induced seismicity. These include seismic monitoring. The RRC has expanded its seismic monitoring network to better track earthquake activity across the state. Data analysis. The agency collects and analyzes data on wastewater injection volumes, well depths, and proximity to fault lines to identify potential areas of concern. Operational restrictions. In some cases, the RRC has implemented operational restrictions on wastewater disposal wells, such as limiting injection volumes or requiring operators to reduce injection pressures. These measures demonstrate the RRC's commitment to addressing the issue of induced seismicity. Section 7, mitigating the risks, measures to reduce earthquake hazards. As the understanding of induced seismicity advances, so too do the strategies for mitigating the risks associated with human-induced earthquakes. These mitigation efforts involve a multi-pronged approach, addressing both the operational aspects of wastewater disposal and the broader need for seismic hazard reduction. Key mitigation measures include reducing injection volumes. One of the most effective ways to reduce the risk of induced seismicity is to limit the volume of wastewater injected into disposal wells, optimizing injection depths and pressures. Adjusting the depth at which wastewater is injected and the pressure at which it is injected can also help to minimize the risk of triggering earthquakes. Identifying and avoiding fault zones. Advanced geological and seismic surveys can help to identify areas where fault lines are present. Implementing real-time monitoring and response systems. Real-time monitoring of seismic activity and wastewater injection parameters can provide early warning signs of potential problems. Mitigating the risks of induced seismicity requires collaboration among scientists, regulators, and the oil and gas industry. By implementing these and other mitigation measures, it is possible to continue to develop energy resources while minimizing the potential for human-induced earthquakes. Section 8, the Science of Prediction, Understanding Earthquake Forecasting. While scientists have made significant strides in understanding the link between wastewater disposal and induced seismicity, predicting earthquakes, whether natural or human-induced, remains a complex and elusive goal. Unlike weather forecasting, which has benefited from advancements in atmospheric modeling and data collection, earthquake prediction involves inherent uncertainties and limitations. Earthquakes occur deep beneath the Earth's surface, making it difficult to directly observe the processes that lead to their rupture. While scientists can identify areas at higher risk of earthquakes based on historical seismicity, geological formations, and stress patterns, pinpointing the exact time, location, and magnitude of an earthquake remains a challenge. Current earthquake forecasting models rely on statistical analysis of past events and geological data to estimate the probability of earthquakes occurring within a specific region over a given time frame. The inherent uncertainties in earthquake forecasting underscore the importance of preparedness and mitigation efforts. Building codes, early warning systems, and public education campaigns play a crucial role in reducing the potential impact of earthquakes, regardless of their origin. Section 9, Conclusion, Balancing Energy Production and Seismic Safety in Texas. The 5.0 magnitude earthquake that shook West Texas on February 14, 2025, served as a stark reminder of the increasing seismic activity in the region and its potential link to oil and gas production activities. As Texas continues to rely heavily on its energy industry, balancing economic interest with public safety and environmental protection remains a critical challenge. The scientific evidence linking wastewater disposal to induced seismicity is compelling, prompting calls for greater regulation and mitigation efforts. Continued research into induced seismicity, advancements in mitigation technologies, and a commitment to responsible energy development are essential for ensuring the safety and well-being of Texas communities. As our understanding of human-induced earthquakes evolves, so too must our approach to managing the risks and ensuring a future where energy production and seismic safety can coexist.